In today's lecture, we are going to see that the phases of compiler. In the previous video, we know that how our language processing system is converted. So the compiler is one of the translator. It convert our pre-processed high-level language into the assembly-level language programs. So for that conversions, we have the several phases. So the compiling is majorly divided into the two phases. That is an analysis phase and synthesis phase. So in the analysis phase, that is a front end of the compiler that checks the grammatical and structure of the program and produces the intermediate code as an output using the symbol table. And next is the synthesis phase, is the back end of the compiler. It get that three address code as an input and produces output as a target program. For that compilation, we have six phases in the compiler. So the six phases are lexical analysis and syntax analysis and semantic analysis, intermediate code generations and intermediate code and code optimization and code generations. So we have the six phases have the specific input and output of the compilations. So the lexical analyzer get the pre-processed high-level language as an input and produces output as a token. So next, the syntax analyzer get the input as a token and produces output as a syntax tree. And third phase is the semantic analysis. The semantic analysis get the input from the syntax analyzer and produces output as a semantically verified parse tree. So what is a semantically verified parse tree means? Suppose in our source program, if there is any type declaration mismatches or any specific array bound informations means that has to be checked in the semantic analyzer. So the output of the semantic analyzer also the parse tree, but the parse tree is semantically verified. Next is the intermediate code generator. That intermediate code generator get the parse tree and produces output as a three address code. Next, the code optimizer and produces the optimized code as an output. And finally, we have the code generation phase. The code generation phase get the optimized code as an input and produces output as a assembly level language programs. So these are all the six phases are required for our compilations. For all the six phases, we have the two common concept are like a symbol table and error handler. So what is a symbol table means? The symbol table, it is a data structure that store all the all the variables, identifiers, whichever are used in our source program. That information that identifiers information is collected first three phases and uses in the last three phases. So the symbol table is common to all the six phases. Next is the error handler. For every phase, suppose the input is correct, it produces the correct output. Suppose if there is any wrong in the input, it produces a error as an output. So for all phases, we have an error handler. So the error handler also the common to all the six phases. So I already know that our total compilation is divided into the two major phases. One is an analysis and synthesis. In the analysis phase, the first three phases are involved in the analysis and the last two phases are involved in the synthesis phase. That is the front end of the compiler and the back end of the compiler. Now we will see the first phase of compiler in detail. So what is the first phase mean? That is a lexical analyzer. So the lexical analyzer read the source program or source statement from left to right, that is analyzes, scanning and produces the output as a token. So for that we have the three terms. One is a lexeme, token and pattern. So what is a lexeme means? Lexeme is the sequence of characters in the source program. So the token is the subsequent token is the pattern that could be identified from the corresponding lexeme. Next is a pattern is a rule to describe that lexemes, describe that token. So the what is the attribute in the token means we have the token name and attribute value. So the output of the lexical analyzer, it is in the form of token name and attribute value. For example, when you are giving that int a comma b means, so our output is int is a keyword and a is an identifier, comma is a separator and b is an identifier. That is a token as a output from the lexical analyzer. Next is a syntax analyzer. The syntax analyzer do that parsing or the tokenizing, also called the parser. So it get the input as a token and produces an output as a parse tree. So for that parse tree construction, it uses the context free grammar as a processing. We use the context free grammar. So the what is a context free grammar means, grammar is collection of the non-terminals, terminals, production rules and star symbol. So based upon the grammar, it checks the construct the parse tree. So the output of the parse tree is a leaf node contains the terminals of the given statement. Whether the given statement is equal to the output of the parse tree means our statement is syntax wise correct. So this is the parse tree. So in the parse tree, the leaf nodes are the terminals and interior nodes are the non-terminals. So in this video we have seen what are all the 6 phases of compiler and what is the input and output of each phases, and what is the analysis and synthesis phase, and the first 2 phases in detail. I hope you will understand that phases of the compiler clearly. Thank you. In next video we will see the remaining phases in detail.